We need to determine the length that we strip back the jacket on the cord. A real simple, fast way to do that is to push the cord into the handle until it bottoms out against the back side, and then mark. What we want to ensure is that the jacket of the cord is fully engaged by the bushing in the cord grip, so we've got 100% contact for sealing and also for strength. Now that the jacket length that you need to cut off has been marked, you can slide the cord grip and handle back onto the jacket, and you can slide it way up, back out of the way. Now I need to remove all the filling, and the next step is to strip back the conductors. And the strip length for a DSN20, which is the device we're doing today, is 1/2 inch. That's in a table in the instructions that come with every receptacle inlet, but we also place it on the device on a tag. So you actually can just use that. That's a true measurement shown there, and you can use that as a gauge. And of course, once you've done a few of these, you don't need to measure each one. You'll get a feel for it and just use your best estimation. And get that conductor in all the way, and bury the conductor insulator into the terminal as much as you can. Now we realize not everyone has a torque limited screwdriver, but use your best judgment again here. We're going to use this to set it at 15 inch-pounds, which is the torque value we would like to have these terminal screws set at. I think you can get an idea of how much torque this 20 amp device requires. You can tell how much effort he's putting into it before it starts to slip, so it's reached the torque level. So it's a pretty good firm fit, but you don't want to over torque because there's a danger of stripping out the terminal screws. The threaded cord grip with mesh comes with 4 components. You've got the threaded hub that goes into the handle. You've got a bushing, which is going to compress up against the jacket. You've got the mesh, and then you've got the capping nut, which is going to hold and pull all this together and compress this bushing against the jacket. So ensure that you have all those components in place and slide them in. And there's no torque level for this nut on the cord grip, other than you should do it nice and snug and ensure that you can see that bushing being compressed tight up against the jacket. Now that we've slid the handle and the cord grip with mesh back into position, we'll install the screws from the receptacle into the handle. Of course, you can use a screwdriver, but if you're installing quite a few of these, a cordless drill works very nicely. And there's no torque level for these screws other than you need to ensure that the gasket is nice and snug and everything's tight. And there we have it. Our cord jacket is terminating somewhere in there. So we've got full contact between this jacket all the way through the bushing and past it. So we've got a very nice connection in there. So our next step is to show you a pull test and demonstrate how much force is required to pull this cord out of a properly installed cord grip and handle. So the minimum pull-out force per the UL for a 20 amp device is 30 pounds. So what we've done is we've set 30 pounds at the end of our cord, as you can see, dangling from a forklift. It's been hanging for a few minutes now. The UL test is for 1 minute. And now we're going to start adding 50-pound increments and see if we can get this to move. You'll see there's a piece of orange tape which is mounted on the end of the mesh of the cord grip going into the receptacle. And if we see that to begin to move, then we know that we've reached a weight limit for the cord grip. So now we're up to 50 pounds. I would just do 50-pound increments. Not yet. We'll let that sit for a bit. So now we're at 100 pounds. Still no movement. And let's throw another 50 on there, Mike. Now at 150 pounds. You see any movement between the mesh and the tape at all?
No, the jacket's beginning to stretch on the bottom.
So the jacket on the bottom is beginning to move, but nothing on top.
50
Yep. Now we're at 200 pounds. Yep. So as you can see, we overcame the cord grip that we used to attach to the end of the cable, but the cord grip into the device itself is still very solid and has not moved a bit, and that took 200 pounds. So if we could develop a better way to attach to the end of the cord grip, our estimation is it would take at least another 100 pounds or more to pull that cord outside or out of the DSN20 handle.